So letter D is just formalizing what happens when we have a function inside. So, it basically, this is just going to be your chain rule, but notice it's very specific. AX plus B, that means when you do the derivative of whatever you see, the AX plus B, that must be a constant. Must be a constant. It cannot be anything else but a constant. All right. So think about when we've done chain rule, where when we're doing derivatives, chain rule, we multiply. With integration, we just divide. So E is just E. So the antiderivative of E is E plus C. And then whatever the derivative of the exponent is, we divide that out or just rewrite it as a fraction in the front. Power rule. Add one and divide, and then divide out that chain rule of the exponent or the inside. Same thing for sine and cosine. And this is the one I'm going to always caution you on, is when you have x to the first in the denominator, it is always ln. And you must use absolute value because you cannot take ln of a negative. But notice the only difference for this whole page, we have 1 over a in front of each one. Everything else is exactly the same. Okay? So, for example, when I look inside, the derivative of the inside is a constant, 2. So I can just integrate, add, use your power rule, add 1, and divide. Then because the derivative of 2x plus 3 is 2, I got to divide that out. Notice when, don't forget your plus c, because I'm putting 2 in the denominator with the 5, really I can just multiply those two together. I'm just going to put that out front as a constant, 1/10, instead of dividing the whole thing by 10. You can either put it in the denominator here, it's just a little bit cleaner if you put it as a coefficient out front. All right, this one's a little tricky. First, I'm going to rewrite the inside as a power. 1 minus 3x. So this is positive 1/2 in the denominator, so move it up top, and it's negative 1/2. So I'm going to add 1 to negative 1/2 to get positive 1/2. Then divide by 1/2 or multiply by 2. Multiply by the reciprocal. Then the derivative of the inside is negative 3. We just divide that out. And I just am going to put it underneath the constant that's already there. This will get a little bit of getting used to for some of you. Just be patient. We'll get there. All right. So let's just take it one step at a time. They're using the verb integrate instead of the symbol. I like the symbol the best. So I'm going to rewrite it using my integral symbol. All right. So we start with e is just e, so I'm going to bring down 2e to the 2x. Because the derivative of the exponent is 2, I'm going to divide that out. Minus e is just e, just bring the whole thing down. Divide out the derivative of the exponent, which is negative 3. Then we just simplify. The 2's cancel. This negative and this negative make it plus. And you could write it 1/3. A lot of the times that's what you'll see mathematicians do. I'd be okay just leaving it all over 3. Either way is fine. So think about anytime you get stuck and you think, well, geez, I don't know if this is right. You can always take the derivative So what would the derivative of this whole thing be? And this is just to check your work to see if you did it correctly. The derivative of E is just E. Doing the derivative, we chain on the derivative with multiplication. So that's where this becomes the 2 plus 1/3 e to the negative 3x. This time we chain on negative 3 with multiplication, and then the c goes away. And then this turns into negative. Oops, sorry. But see, we're dividing these two out here because that we have to cancel that out. And so that's why we're chaining on. Whenever we chain on with integration, we chain on with division, where with derivatives, we chain on with multiplication. Okay? All right. So integrate. Be really careful with sine and cosine. You're just so used to sine is positive and cosine is negative. I would, every time you're doing your calculus on the IB test, I would always refer back to your formula booklet. Just don't even chance it. All right. All right. So the antiderivative of sine is negative cosine. So I need to keep my negative, my 2, my coefficient. Cosine 3x. Chain on the derivative of the inside with division. Plus the antiderivative of cosine is sine. Chain on the derivative of 4x plus pi with division. I'm just going to make that as a coefficient of sine out front plus c. All right, this one's a little bit sneaky because first of all, I kind of want to point out we can't chain anything on because your antiderivative or your derivative here is not a constant. So therefore, you cannot just do the power rule. All right, so the first step, and this one's going to take all your space. I'll just tell you that right now. So the first step we need to do is square the quantity. So 4 minus 4 sine x plus sine squared x. If you need to actually write this out and distribute it to get what I got, that's fine. Just use it up top a little bit. Okay, here's the problem. There is no antiderivative for sine squared. So we have to use one of the double angle theorems. And you won't remember this, but I think it's in the formula booklet. So I'm going to write this. I would write this up top above this problem so you see where this came from. You can integrate double angles because the derivative of the inside is a constant. You cannot integrate sine squared. So anytime you see sine squared or cosine squared, you'd have to replace it. So the double angle that we're going to use is this one. Cosine actually has 3 double angles and it helps out with a lot of integrations. All right, so I want to solve for sine squared. So I'm actually going to add 2 sine squared to the left and subtract cosine 2x to the right, because then that makes my sine squared positive. Then I divide everything by 2. And so I'm writing this way. Because you never see trig functions divided by a number like this. You always just pull that out front to make a coefficient out of it. So we're going to use the fact that sine squared equals all of this, and I'm going to substitute this in here for sine squared. I would be very surprised if this would be on an IB test, but I will tell you, for any of you going into calculus, if you need calc in college, you're going to need to know this. All right, now I can combine like terms. 4 plus a half, 4 1/2, or 9/2. Now I'm ready to integrate. So this is almost the easy part after all of this. All right, 9/2 is a constant. So it just needs an x. The antiderivative of sine is negative cosine, so that changes that to a plus. Antiderivative of cosine is positive sine. Then we have to chain on the inside by dividing by 2, and that just goes into the denominator with the 2 that's already there. So technically, we got to rewrite this whole thing. If you see this and just can multiply in your head before we do that, that's fine. Okay, so that, in my opinion, this is the worst one. First of all, you have to recognize you have to distribute this here. And if you see sine squared, you have to use this whole process to substitute in. All right, last example has to do with our ln, because when you look at the denominator, so we're using our general concept that the derivative of ln x is 1 over x. That's why the antiderivative of 1 over x equals ln x. And we always use absolute value with ln because I don't know what this x is, so we need to make sure it's always positive. So just like 1 over x is ln, any combination of a constant times x plus or minus a constant. Okay, this is all ln. All right, so our antiderivative is ln plus c, but because the derivative of the inside is 5, I have to divide that 5 out, or just make it a constant, a coefficient of 1/5. Dividing by 5 or multiplying by 1/5 is just the same thing. And same thing here. I'm going to pull this 4. Watch this. And this might help make a little bit better sense of this part, because typically we want a 1 on the top. So I can just pull that 4 out and take 4 times the whole thing. So then I bring down my 4. I take ln of the denominator, absolute value, plus c. Then the derivative of the inside is -2. I have to divide that out, but I already have 4 on that outside, so I just divide that 4 by -2. And that's ln.